Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the important concepts of binomial expansions with examples. For this lecture, I am using the work of one of my best students, Miss Laiba Gulzar of class 2021, the Lyceum. An important advice: be simple yet graceful. Binomial expansions. In this chapter, you will learn how to expand expressions of the form 1 plus b whole power n and a plus b whole power n, where n can be any positive integer, for example 3, 4, 5, 6, 7 and so on. Expansions of these types are called binomial expansions. The word binomial means two terms. These are some examples of binomial expansions. Combinations. We use combinations in binomial expansions. These rules will make the calculations simple. NC0. NC0 is 1. Whenever this number is 0, the answer is always 1. For example, 5C0. Because of this 0, answer is always 1. When both numbers are same, answer is also 1. For example, 5C5 is 1. When this number is 1, then answer is always this number. Like 5C1 is 5. Combination rules in factorial form. Well, use these rules when n, the power of the expansion, is unknown. NC1 can be written in this way: n upon 1 factorial. Since this number is 1, therefore this must be 1 factorial. See, this number is 2, so this should be 2 factorial. Since this is 1 factorial, so we must have just one term in numerator, n. This is 2 factorial, so we must have two terms in numerator in descending order, n minus 1. This is 3, so this must be 3 factorial, and we must have 3 terms in numerator in descending order, n minus 1, n minus 2 and so on. Binomial expansions of 1 plus b whole power n and 1 minus b whole power n. This is the way to expand this expansion. So 1 plus b whole power n can be expanded in this way: 1 plus nc1 second term b with power this number 1. nc2 second term is b with power 2. This number is the power of the second term. And when we have positive sign, then all signs are positive. When we have negative sign, then signs are alternate. Always expand the theorem with alternate signs. First term is 1. NC1 second term has this number is power. This is 2, so this power of second term is 2. This is n, so this should be n. And the signs are alternate. Make sure you use these two theorems when the first term of the expansion is 1. Example. Obtain the first 3 terms in the expansion of. Since this is similar to this, therefore I will use this theorem to expand this expansion. So 1 minus 2x whole power n can be expanded in this way: 1 according to this theorem, then sign is negative because this sign is negative, so signs are alternate, plus minus and so on. Then 9c1 because n is 9, second term 2x with power 1, which is this number. This is the power of the second term. and this is the simplified form of this. Now this is very important. Never take this negative sign of the second term while using the theorem. See, I took positive 2x. I did not take negative sign here. Here we had minus b, but I wrote b here. So never take the sign of second term while using the theorem. Now binomial expansions of a plus b whole power n and a minus b whole power n. So if we have this expansion, we can expand this in this way. First term with this number as the power. Then since this sign is plus, so all signs are plus. NC1 and first term with this power n minus 1. The difference of these two numbers is the power of the first term. And then second term power 1, which is this number. This number is always the power of the second term, and the difference of these two is the power of first term. And see, the power of first term is decreasing, whereas the power of the second term is increasing. But you can learn this in this way. This difference should be the power of the first term, and this number should be the power of the second term. So when we have NC2, then first term has power n minus 2, which is the difference of these two numbers, and second term has this number, the power. When the sign is negative, then all signs are alternate, plus, minus, and so on. And don't take the sign of second term while using the theorem. Second term is always positive. Well, use these two theorems to expand the expansions of all types. Example, obtain the first three terms in the expansion of. This is similar to this. So I will use this theorem to expand this expansion. So first term is 2 with power 10. Now put negative sign because signs are alternate because of this negative. Then 10c1, according to this theorem, first term with power 9, which is the difference of these two numbers. Then second term with power 1, which is this number. Then put plus sign according to this theorem. 10c2, 2 to the power 8, which is the difference of these two numbers. 10 minus 2 makes 8. And second term with power 2, which is this number. Now just simplify this. This is the simplified form of this. And this is the way to expand the expansion of this type. The nth term formula. As we know this theorem, so if we replace all ones, all these three ones by r, then we will get this formula. See, if we replace this by r, we will get NCR. This will become a to the power n minus r, and this will become b to the power r. This is the way to form the nth term formula, or you can learn the nth term formula in this way, where this n is r plus 1. That is, r is 1 less than n. It means if we have n7, then r should be 6 according to this formula. 7 r plus 1, so r is 6. And if we have r10, then n must be 11, because according to this formula, 10 plus 1 makes 11. Well, this formula Tn or Tr plus 1 is used to find the indicated or particular or specific term without expanding the expansions. You don't need to expand the expansion. You can directly find the particular term with the help of this formula. And this is very important. Make sure you take the second term with its sign while using the Tn formula. Means the second term is negative here, so you have to take second term with its sign while using Tn formula. Example, find the term independent of x. Independent of x means the constant term. Constant term means independent of x, and they both means x power 0. So we will use Tn formula to get this term from this expansion. So n is 9, a is x, b is negative 5 upon x square, and r is unknown. For r, use Tn formula. So this is the Tn formula. We just need to substitute all these values into Tn formula. After the substitution, we'll get this thing. Now just consider x from this formula to get the value of r. So when you will consider this x, you will get x power 9 minus r. Just consider this x. This is 1 upon x square power r. Just consider this here. Don't consider minus 5. Just take x. So this is here. When you will simplify this, you will get x power 9 minus 3r. Now you should equate this with the requirement, which is x power 0, to get the value of r. When you will equate this with this, you will get r3. After getting the value of r, substitute r back into this equation to get the answer. This is here. See, when you will substitute 3 here and here, you will get this thing. And when you will simplify this, you will get this answer. This is the constant term. Types of questions. Type 1. Find the first 4 terms in the expansion of. This is part 1 and this is part 2. Hence, the word hence means use the answer of previous part. Find the coefficient of x square in the expansion of. So, in type 1 question, we just need to follow the sequence of the question. We just need to expand this, and then we will use this expanded form in the second part. So first we need to expand this with the help of a minus b whole power n formula. According to that formula, we need to write first term with power 6. Since this sign is negative, so signs are alternate. This is plus, this is minus, and so on. 6c1, first term with power 5, which is the difference of these two numbers, or the power of first term decreases by 1. And second term without its sign, 1 upon 2x with power 1, because when we use theorem, we never take this sign of the second term. We take second term without its sign. Then 6c2 and so on, and finally 6c3, because we need first 4 terms. That's the final answer of part 1. Now we will use this answer here to solve this second part. The word hence means use this answer here. See, this is here, and then you need to substitute this thing here, the answer of part 1. And the question is find the coefficient of x square. So you need to multiply only those terms which will give you the requirement. You need to multiply 1 with this 60x square and x square with this, because you need coefficient of x square. You don't need to multiply this with this or this with this. So when you will multiply x square with this, you will get minus 20x square. When you will multiply 1 with this, you will get 60x square. You just need to subtract these two, 40x square, and the answer is 40. Make sure you give your answer without x square, because coefficient is required. This 40 is the coefficient. of x square. Type 2 question. In this type, the same expansion is used in the later part or parts. Method. Whenever the same expansion, you can check the example first. See, same expansion is used in the later part. This is type 2 question. So when the same expansion is used in the later part, then always expand the first part, the expansion of the first part. Always expand this to make the calculations of second part simple. Now, see, same expansion is used in the later part, so I will expand this expansion. The question is find the term independent of x in the expansion of. So I have to expand this. So when you will expand this, you'll get this thing, x power 6, first term to the power 6, then 6c1, x power 5, which is the difference of these two numbers, 2 upon x power 1, and so on. That's the expanded form of this expansion. We need independent of x, which is minus 160. Write your answer in this way. But see, I will use this expanded form here to make the calculations of this part simple. See, I substituted this here. Now I need the term independent of x, so I need to multiply 2 with this. Independent of x means constant term, and this with this. When you will multiply 3 upon x square with this, x square will be cancelled and you will get the constant term. So your answer is minus 40. See, second part became very simple when we use this answer here, when we expanded the first part. So this is the way to solve these type of questions, and this is the best way. Type 3 questions. In this type, the variable of the second term of the first expansion is replaced by another variable to make the new expansion for the later part. Now understand this thing with the help of this example. See, the variable, check this, the variable of the second term of the first expansion, this variable. Understand this statement. The variable of the second term of the first expansion, this is y, is replaced by another variable to make the new expansion for the later part. See, this y is replaced by 2x minus x square. Now, this is very simple. What makes this question unique is that the binomial in the second part is very similar to that mentioned in the first part. Both are same. The question requires us to solve these two parts together and not separately as suggested by the word hence. We have to use first part to solve this part. For that we need to replace y with this thing in the answer of first part. See, first we need to solve the first part, we need to expand the first part. These are the first three terms of the first part. Now to solve this part, you just need to replace y by this thing here. If you replace this y, all the y's, by this thing here, you will get your answer. See, 32 is here. Just need to replace y, this y and this y square by this thing to solve this part. So this 32 is here, minus 80 is here and y is here. 80 is here and y square is here. Now you just need to expand this. You need the coefficient of x square. See, we expanded the first part and then we replace this y and this y square by this thing to expand the second part, because both parts are similar. The difference is just the second term. y is replaced by this. So you need to replace this y and this y square by this thing, and you'll get your answer. Type 4 question. The specific term without expanding the expansion. This is the type 4 question. We always solve this type with the help of this formula. These types of questions have just one part, like this thing. Find the term independent of x and the expansion of. This is very simple. You just need to substitute all the values, like value of a, n, a, b into this formula to get the value of r. You just need to consider x from this. When you will consider only x from this, you will get x power 6 minus 2r. Now you should equate this with the requirement, which is independent of x, means x power 0. So when you will equate this with x power 0, you will get the value of r. So according to this type, we just need to substitute everything into this formula except r, because we are working for r. And after the substitution, call this as equation 1, and then just consider x from this equation, and then equate this x with the requirement, which is x power 0 in this question. After getting the value of r, substitute r into equation 1 and you will get your answer. Your answer is minus 135.2. We substituted 3 here and here and here. Next question, type 5. So the power of the expansion is unknown. This is very important. So whenever power of the expansion is unknown like this, we always use these forms to expand the combinations, factorial forms. I have discussed these things earlier in this lecture. So when this is expanded in ascending powers of x, the coefficient of x square is 4. Find n. Coefficient of x square means r is 2, because this expansion is simple, so you can predict the term. For x square, find t3. So when you will find t3, you will get this thing with the help of this formula. So this coefficient is 4. Just need to equate this with 4. Now you need to simplify this with the help of this. When you will solve this, you will get two values. Make sure you take positive value, because n is positive integer. When expansion is simple like this, then you can predict the term. For x square, you need t3, because this 2 means r is 2. This expansion is simple, that is why I predicted the term directly. But here you cannot predict the term. This is not simple. So whenever we have these types of question, we always use tr plus 1 formula to get the value of r, and then we substituted r here to get the answer. But when we have these types of expansions, simple expansions, x power 1, we can predict the term. For example, if the question is find x power 4, then r should be 4. That means t should be 5. Example 2. We have to solve this. We need n, p and q. So you just need to observe this question carefully. See, this is the expanded form of these expansions. So you need to expand these two up to and including the term x square. This has power 1, so you just need to copy this. You need to expand this till x square. So 2 power n. Let me zoom in this. Then nc, because of this negative, signs are alternate. nc1, 2 power n minus 1, x upon 4 power 1. Then nc2. Now you need to multiply 1 with all and x with this and this. No need to multiply x with this, because this will become x cube, and which is not required. So when you will multiply these two, you will get this thing. Make sure you multiply these two carefully. Now you need to equate the coefficients of like powers of x on both sides. P plus 2x square means p plus 0x plus qx square. When x is missing, it means 0x, which is here. So this is constant and this is constant. So p is 2 power n. So p is 2 power n. Coefficient of x, coefficient of x. So this plus this is equal to 0. Now you need to solve this for n. Therefore n is 8. When you will simplify this, make sure you simplify this carefully. According to rules of indices, you can write this as 2 upon 1. 2 power n minus 1 can be written as 2 power n upon 2 power 1. When you will put 8 here, you will get p, which is 256. Now you need to compare coefficient of x squares. This and this with q. By substituting the values of n here and here, value of n in fact, we can get the value of q. This question is very important, calculation wise. You must be good at algebra to manage the calculations of this type of questions. This is very important. This comparison is also very important. A lot of algebra is required. If you need this PDF, you can WhatsApp me and I will give you the PDF. Type 6. The expanded form of two expansions will be given like this. So this is very simple. You need to expand both the expansions first, and then you need to expand both the expansions up to and including the term x square according to this question. First expand this, then expand this. Let me write bracket here. So first expand this, then expand this, and then multiply these two up to and including the term to get the expansion up to and including the term x square, and then compare your expansion with the given expansion. This is here. The expanded form of two expansions will be given like this. Follow the following steps. Expand both the given brackets. Now multiply these brackets. Multiply those terms which will help you to get the desired terms of x instead of fully multiplying two brackets. Now compare both the expansions. See, I explained this here. First expand this separately and this separately, or you can do this in one step like this. This is the expanded form of this expansion, a minus b whole square. Here you have to use binomial. You have to expand this till x square. Now you need to multiply selected terms of these two expansions. You need to multiply one with all, 4x with this and this. No need to multiply 4x with this because this will become x cubed, which is not required. And x square with this only. This 4x square should be multiplied with 1 only. And this is the mention. This thing is here. Now multiply these brackets. Only multiply those terms which will help you to get the desired terms of x instead of fully multiplying the two brackets. We did not multiply these two brackets completely. We just multiplied the selected terms. And we got this answer. Now the last step is compare this expanded form with the given expanded form. So both are same. Coefficient of x, coefficient of x. So 6a minus 4 is equal to minus 1. So a is half. 15a square minus 24a is equal to plus 4 is equal to b. So this minus this plus this is equal to b, which is minus 17 upon 4. Type 7 question. Part 3 will be solved with the answers of part 1 and part 2. Method. Use the substitution to expand the last part, that is part 3, and then use the answers of part 1 and part 2 to get the answer of the last part. I explain these things with the help of this example. See, the question is find the coefficient of x power 8 in the expansion of this. This is very simple, 4 to the 8. So last term is the x power 8, which is t5. So first you need to expand, you need to get the fifth term of this expansion to get this answer. So for x8 in this expansion, r is 4, therefore t5, so the answer is 81. I explain these things while solving this part. For x power 8, in this you need to find the value of r first. We don't know which term is x power 8 here. So first substitute for x power 8 things into this formula and get the value of r. So x power 5 plus r should be equated to x power 8 to get r. So r is 3. Here we predicted the term because 4 to the 8 last term, so t5. Here we cannot predict the term easily. So we need to get r with the help of this formula. And for part 2, r is 3. So by substituting 3 into this equation, we can get the answer. Now, this thing, this explanation, this method. See, if you observe last part, then you will see that this second term is exactly same as this expansions. I mean both the terms of this expansion or this expansion. This is same. So use the substitution, like you can use a here to expand this expansion first and then use the answers of first two parts to find the answer of this part. This is here. Use the substitution to expand the last part, this part. You can expand this in this way, 1 plus a whole power 5. And then use answer of this part and this part to get the answer of this part. This thing is mentioned here. The question is, find the coefficient of x power 8 into this expansion, this one. So I will use substitution. So first substitute this by a, now expand this fully. So when you will expand this till the last term, you will get this thing. Now substitute a by this thing. So this is the expanded form of this expansion. 1 plus x plus 3x square whole power 5. Till here. Now you have to compare this answer or this expanded form with these two expansions. See, this is x plus 3x whole square power 4 and this is power 5. So this is here, this is part 1. This thing, this expansion is used in part 1, whereas this expansion is used in part 2. So with the help of the answers of part 1 here and part 2 here, we can get the answer of this part. So we just need to write the answer of part 1 here. So answer of part 1 was 81. Coefficient of x power 8 in this expansion was 81. So its answer is 81, so this should be multiplied with 5 because 5 is coefficient. And the answer of this was 270. So this should be here. So this is part 2 and this is part 1. Hence this is the final answer of last part. Coefficient of x power 8 in the last part is 675. Note, the coefficient of x power 8 can only be possible from the last two expansions because of the higher powers of the last two expansions n4 and n5. I mentioned this thing here and here. Now check the solution again. First, get the answer of this part and this part. These two parts are very simple. Here you could predict the term, which is R4, so T5. Here we could not predict the term, therefore I used TR plus 1 formula and I got the value of R, which is 3, and then I substituted R back into this equation 1 and I got this answer. Now this part is very important. The second term is exactly same as the whole expansion of part 1 or part 2. So I use substitution, I use A here and I expanded this till the last term. And then I check this expansion with the first part and second part. This is the expansion of the first part and this is the expansion of the second part. I have the answers of this part and this part. I just use those answers here and here. And I got the answer of this last part. Well, this is all. I hope this lecture will help you to understand the concepts of binomial expansions. An important advice for me and for everyone is spend a good pious life. Good luck and Allah Hafiz.